Getting into chapter 14, we are now combining our knowledge of trig with the calculus that we've learned this year for this last chapter. So a couple rules that you need to know for this, and these are in your formula packet, but the derivative of sine is cosine, and the derivative of cosine is negative sine. And so I'm not going to go into all the depth on why that is what it is, because I want to keep the video short for you, but those are two values that you just need to be aware of, and they are in your formula packet. So let's go through a few examples together. So if we're going to find the derivative of the sine of 6x, one thing I really need you to keep in mind of this is that concept of chain rule. These are really commonly missed problems, and I tried to stress this when we learned chain rule earlier on this year. But anytime you do a derivative of a function like this, where you have an interior function of 6x, or whatever that interior function is, chain rule says that you have to multiply by the derivative of the interior function. And so you got to pay attention to that. So two things going on here. One is that the derivative of sine is cosine. So we get the cosine of 6x. I should say 6x. So cosine of 6x times the derivative of the interior function. So the derivative of 6x is 6. And so we also have to multiply by 6. So this should read 6 cosine 6x. If you have terms separated by a plus or a minus sign, just do each term individually. So the derivative of 1x to the first is 1, just using our power rule. Derivative of cosine of 5x, again, we know the derivative of cosine is negative sine. So that's what you're seeing right here. So we're going to have the negative sine of 5x. And now we have to multiply by the derivative of this interior function that you see right here. So the derivative of 5x is 5. So we have to multiply by 5. And if you do a little cleanup on that, this is the proper way to write that answer. As always, at any time, I'd encourage you to pause video and try a couple before I go through them. When it comes to exponents, when you have the cosine cubed of x like you have here, the one way to write that would be to just see it as the entire thing to the third power. That means the same thing. And so if we use our power rule on this, where we multiply the 3 to the front and then subtract 1 from the exponent. So we're multiplying 3 to the front, subtract 1 from the exponent, and it is now to the second power. But again, you have an interior function right here. This is chain rule. So if you multiply by the derivative of the interior function, you get negative sine x. And so if we bring that all together, here is the proper way to write that answer. Getting down here to part E. Again, when you see that squared right here, this is the more friendly way to write that for our purposes. And so if we bring that whole thing up top with a negative exponent, here's the easiest approach, and now you can use chain rule to solve it. So you're going to multiply your negative 2 to the front. You're going to subtract 1 from your exponent. And here's the first step of taking the derivative. And then the second step is now to multiply by the derivative of the interior function. And so if I multiply by the derivative of sine of 3x, well, derivative of sine is cosine. So I have cosine 3x. But now, just like I was doing in the previous problems, I have another interior function right here that I have to now multiply by the derivative of him as well. And so that's where we get the other times 3 that you see out here. Bring it all together, and we come out with this look that you see here. And so we're bringing the sine of 3x down below because of the negative exponent that he has. And you can bring the 3 back inside, or you can just write the whole thing as sine of 3x cubed if you want in parentheses. Either way is fine. Again, part F, I would encourage you to pause right now and stop and give this one a try. But the more friendly way to write this would be to a 1/2 power instead of a square root. But now just move forward with your chain rule process. So I'm going to multiply the 1/2 to the front. We're going to subtract 1 from the exponent. And that's what you get for the first step with the use of chain rule. Notice on that first step, when you're just doing the powers, you leave the interior function alone. but now we take the extra step of multiplying by the derivative of your interior function. So the derivative of cosine of anything is negative sine of that value. Now again, you have another interior function. And so the derivative of 6x minus 1 is 6. So I have to make sure that I throw this in. This is one of the most commonly missed things that we run into all year, is people not multiplying by the derivative of the interior function. So you got to make sure that you're doing that. And this is where that would finish after some cleanup. And again, you could leave the 1/2 power. You don't have to put it as a square root. Either way would be fine. These last two, extremely common test questions. Make sure you're familiar with these. The first one is product rule. So you have to recognize on this one that I am multiplying these two terms together. So we have to use the product rule. So I'm doing the first times the derivative of the second plus the second times the derivative of the first. That's our product rule. So we have our first term, which is x squared, times the derivative of the sine of 4x. And so the derivative of sine 4x, just do what we were doing up above for these derivatives. So we know that the derivative of sine is cosine. So that's where we're getting the cosine of 4x. And now I have to multiply that by the derivative of the interior function. So derivative of 4x is 4, and that's where he comes from. And so you got to make sure that you include that derivative of the interior function. So that's the first half of the product rule. Second half says your second term times the derivative of the first term, and that's where you get this look here. If you do a little cleanup on that, we can bring it down to this look here. You do not have to factor out a common factor of 2x like they did. That's where this is coming from. You could do it either way. So this would, on an IB test, that would probably be accepted for full credit as your answer, because there's really not a lot to simplify. You can factor out the 2x, but it's arguable that this is not necessarily simpler than what we have right here. And so you could probably have just kept it at this stage, but you do want to simplify as much as you can if there is something to simplify. Right here we have a quotient rule. So we got our low d high minus high d low over low squared. And so we have the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And so here we have with the quotient rule that you see over here on the right. So if you want to pause and give that one a try first, that would be good. But I have my bottom term times the derivative of the top minus the top times the derivative of the bottom. So if you look down there at the bottom, this is our new concept for today, derivative of cosine x plus 1. Remember, that constant's going to go away, the plus 1. But the derivative of cosine, of course, is negative sine. And so that's where this one comes from. And then you have the bottom squared. So again, on this one, you do want to simplify as much as you can. Notice you're going to leave this as just a function squared. You don't have to FOIL. Just leave it alone. Keep it like this. On top, if you do want to factor out a common factor, they both had an x in them. And so this would be, probably the most appropriate way to write this answer. But again, if you left it like this, the one thing I would say that you do need to simplify is the double negative. That should become a plus. We tend to move single terms like this to the front of their function. So like we put the 2x right here. That's just a common way of writing these answers. But the only thing I would say you have to do for sure to simplify would be to take care of the double negative. Other than that, it's just a matter of reformatting your answer. And this would be the most appropriate way to write it, that right there. Slope of the graph, that just means working with the derivative, right? Derivatives are slopes or gradients. So if we take the derivative of that function, sub in an x value, then we get our answer, our slope or our gradient. So the derivative of 3 cosine 2x. So again, as always, we know the derivative of cosine is negative sine. So that's what this should be, negative sine. So when we had the cosine of 2x, derivative would be negative sine 2x times the derivative of the interior function. And if you clean that up, this should say negative 6 sine 2x. And now we can sub in the x value of pi over 6 to get our answer. So when we get to this stage right here, the sine of pi thirds is rad 3 over 2. So the answer is right, but that just should have said sine instead of cosine. You really need to know those first quadrant values. This is another commonly missed area on the test. Students will put a 1/2 right there, or they'll put some other value. Won't necessarily know how to convert this. So make sure that you know how to do that. So the sine of pi over 3 is rad 3 over 2 times -6. A little cleanup, and we got that rule right here. When you do a derivative of tangent, again, you can see where this comes from. I'm not going to go into the depth on that. The rule that you need to know is that the derivative of tangent is 1 over cosine squared of x. Since 1 over cosine is the same thing as secant, you can see this as the secant squared of x. But for our purposes for IB, since this is what's given to you in your formula packet, stick with cosine squared, or 1 over cosine squared. Don't use secant squared. So on this one, again, just going through the chain rule process. So the derivative of tangent of anything is 1 over cosine squared of that value. Then you got to make sure that you multiply, as always, by the derivative of the interior function, and the derivative of half x is 1/2. And so we got to make sure that we do that. So we're multiplying by 1/2, and that's where you get this idea of 1 over 2 in our answer. Right here again, derivative of tangent of anything is 1 over cosine squared of that value times the derivative of x squared. So that's where the 2x comes from, and we finish it off with that right there. Feel free to pause and give this guy a try, but again, when you have a function squared, you can just bring it outside like this. Now use our chain rule, so multiply the 2 to the front, and we get this look right here, times the derivative of the interior function. And this whole thing is now your interior function because of the 2 outside. So derivative of tangent of something, again, is now 1 over cosine squared. You have another interior value, so the derivative of this is 3. You got to make sure you get all these steps right here. All this has to be included to get this right, but a little cleanup, and we can write it as this right here. Right here we have a product rule, so you're multiplying two x values together, so we got product rule. So you got the first times the derivative of the second plus the second times the derivative of the first. And so that's where each one of those is coming from. So make sure you know how to do that. You can expect some kind of a product rule or quotient rule question on tests, final exam, IB test. They're all going to be there. So this is one you got to make sure you can do. Slope of the graph always means derivative. So again, we're just going to plug in a value here into our derivative. So we have 1 over the tangent of x. So if we put that into friendlier terms, it's this look right here with a -1 power. Now if we go through with our chain rule, multiply the -1 to the front, subtract 1 from your exponent, and then multiply by the derivative of the interior function. So tan was our interior function, so derivative of that is 1 over cosine squared. That gives you this look right here. And from here, you're going to need to do a little cleanup since you have to sub in pi over 6 in for x. We want to make sure that we put this into friendly terms to work with when you do that. You could do it from here, but if you were to do a little cleanup on that and get it all the way down to this stage, it's just a little simpler to do. So now if I sub in my pi over 6, that's what you're seeing right here. So the sine of pi over 6 is 1/2. And now we get to finish it off with this value here. For this last part, this one says find stationary points. Anytime you see that, you always need to know that the derivative equals 0 for a stationary point. So I'm just going to find the derivative of this with the product rule. So please look through this. That's what you're seeing right here. So we got the derivative with the use of product rule. We're setting it equal to 0 because it's a stationary point. These are the same equations that we've been solving in chapter 13, so please look through it in order to see what the answers are that we're coming up with, but that's review of chapter 13 for the rest of that problem. Last one right here, find the max value. Again, anytime you see max or min, those are stationary points. So again, you would set your derivative equal to 0 to solve for it. So again, you're doing another product rule right here. So please go through it. We're setting it equal to 0 since we were finding a word max. Again, max or min are your keywords for setting a derivative equal to 0. If you solved it, you'll notice in this case you come out with tangent of x equaling -1. Well, where does the tangent of x equal -1? Well, we know tangent of x equals +1 right here at 45 degrees, which is pi over 4. So at -1, it's right here at 3 pi over 4. And so that's the one that we're looking at for this. Since it says a max value, that's always in reference to the y coordinate, not the x coordinate. So you got to take your answer of 3 pi over 4, plug it back in for x here and here in order to get the answer. This is the max value. So this was the x coordinate, but it's the y coordinate that represents a max or a min.